You are welcome to my channel. In this video, we'll be solving a question from West African Senior School Certificate Examination of June 2014 for school candidates. June is for school candidates, and we'll be solving question on Lamina. This is the question. That's question 2, Lamina. The first thing you need to do to solve this type of question is to first of all analyze your question so that you know where to place your drawing. Now, one thing that is very, very important after you have drawn the vertical view plane, view on the vertical plane and view on the horizontal plane, you now check for the one on the vertical plane, which of the corners, such that when you project it to the left or to the right, it will intersect with one side of the same lamina. Now, if you project this one to the right or to the left, it cannot intersect with anything. But if you project this one to the right, definitely it will intersect with this side. So we can use that one. Let's check this one too. If you project to the right or to the left, it cannot intersect with any side, meaning that our drawing will go this way. So definitely our drawing will move in this direction. So you have to place your given view to the left side of your drawing sheet so that you have enough space to play around with. So let us start by drawing a horizontal line first. I'll draw a horizontal line. So what I'm going to do, I'll move my video a little bit, my camera a little bit to the left. So now let us begin to plot. We'll draw a vertical line first. That's the first thing. You draw a vertical line. A vertical line from this side. Draw a vertical line like this. Then begin to take the measurement. Now what are the measurements? For A1, the distance is what? 25. For B1, it is 15. And for C1, it is 60. So we're going to measure 15, 25, and 60. Let us measure that for the vertical plane. 15. Yeah. Okay, 15. Then this will be 25. Then 50, 1, 2, 3, 4, 5. This is 50. Now for the one on the horizontal plane, we have 20 for B, 35 for C, and for A is 50. So we are measuring 20, 35, and 50. 20, 35, and 50. This is 20 from the XY line. This is 35, and 50 will be 1, 2, 3, 4, 5. 5. This one is 60. Let me confirm. This one is actually 60, not 50. Let me confirm that. 1, 2, 3, 4, 5, 60. 60 is here, so this one is out of it. Need to erase it so it doesn't cause confusion. Yeah. So now we need to measure the horizontal alignment. So from here to A to B is 28 and B to C is 25. So I'll measure 28 and then measure 25. This is 28, and from this place you measure 25. 1, 2, 5, 25. So that will be the extent of my view. So let me draw horizontal line from those places. I mean vertical lines. Of course, we are still going to draw horizontal lines too. Vertical and vertical. Then I'll draw horizontal line from the other point. This, 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 and finally this. So now let us begin to locate our point. If you check it very well, you see that for this view we have A to be on 25, the second line, and at the left side. So our A will be here. I think that is A1. Then our B is 15. Yes, 15, and in the middle. From the XY line, this is 15. So this is where my B will be. This is my point of my B, and my C will be 60 at the far right. 60, this is 60 here. So we can join now. This is B1, C1. So let us join now. And join this. Now that's the view on the vertical plane. Now view on the horizontal plane. Don't forget, this is our XY line. For the horizontal plane, our A is on the far left and it is 50. So our A will be here. Then our B will be 20 in the middle. This is 20 in the middle. So this is our B. Then our C is 35 from the far right. 25 from the far right. 25 is here. Like this. This is our C. So let us join now. To be this to this and this. So that is the view of the lamina on the horizontal plane. Now the next thing is to now begin to solve, and the first thing we're going to solve for will be auxiliary elevation. The question actually said we should draw the true shape of the lamina, measure and state the angle of inclination to the horizontal plane, then measure and state the length of the true length of AC. Then he said we should indicate this on our drawing, the auxiliary elevation and auxiliary plan. So the first one we'll do is to draw the auxiliary elevation. And to draw the auxiliary elevation, the first thing you're going to do is to project a vertical line downward. Like I told you, you look for which of the corners that. So I told you that you look for which of the corners, the three corners of the lamina on the vertical plane, such that by the time you project a horizontal line from that corner, it will intersect one side of the same view. So this one, by the time you project it horizontally, it will intersect this side, BC. So let us now, you now bring that one vertically downward. You bring it vertically downward like this until it intersects one side of the one side of the view on the horizontal plane. Now that it has intersected this one, you now join this point to the furthest corner of the line of the view. From this point, the furthest is this. So you take it like this and you draw a thin line like that. Now the next thing is to draw parallel line to this line from B and to C. So how do you do the parallel line? The first of us put it on the line that you want to draw parallel line to, like this. You put it on it like that. Then you place the other one behind it and shift it to B and draw parallel line. Then shift it to C and also draw parallel line. So after doing that, the next thing is to draw perpendicular line. Don't draw parallel line to this one. It's a perpendicular line to these three lines. So how do you do that? You put it on one of the lines like this. Put it on one of the lines like this. So you put this one here, put it firmly, shift it a little bit backwards, then you now place this one on it so that you can draw your perpendicular line like this, and you draw perpendicular line. You can see that this line is not parallel to this. It is actually perpendicular to these three lines, 1, 2, 3. So now we begin to plot for the point for our auxiliary elevation. Now I want to start with B, because this one we are working on the horizontal plane, so we're going to take our dimension from the vertical plane, and this is our B on the horizontal plane. You go and take the value of B on the vertical plane. So value of B is from here to here, which is 15. Let me see it again. Yes, that's 15. So we measure 15 from here, from the XY line. 15, 1, 5. That is 15. And don't forget, this is our X1, Y1 line. So now that you have measured that one, then let us do for B. For A, you go to check the value of A on the vertical plane. That's from here to here, which is 25. 25. So it is 25. So we come to the XY line and measure 25. That's for A. It will be from here. You measure 25. 1, 2, 5. That's for A. A2. This is B2. This one is A2. Then remain C2. So you go and check for the value of C on the vertical plane, which is from the XY line to this, which is 60. So you measure 60. Let's extend the line a little. 60. 1, 2, 3, 4, 5, 60. This is 60. Then you join the three lines with a straight line. If you have done it correctly, it should give you a straight line. So you draw it like that. So that's our auxiliary elevation, and the question says that we should indicate on our drawing. So you mark an arc like this. I know, not an arc, arrowhead, and you write auxiliary elevation. That's the auxiliary elevation, and immediately we can determine our angle of inclination. That is this one. It says draw the true shape, measure and state the angle of inclination to the horizontal plane. To do that, you extend your auxiliary elevation until it intersects with the X1, Y1 line. Let us extend it a little like that. So you now extend this line, the auxiliary elevation, until it intersects with the X1, Y1 line. Yes, it is intersecting at this point, so you measure this angle. And that angle, let me put arrowhead so that you know it is just not just an arc. So measure the angle. By the time you measure the angle and you state it, not just to measure it alone. So to measure the angle, I'll put the cross here on the corner and the line at the bottom on the X1, Y1 line, like this. Set it very well. Yeah, I think it's better like this. So you count 10, 20, 30, 40, 50, 60. That's 60 degrees. 60 degrees. That's angle of inclination to the horizontal plane. Now the next and the last final part of our question is to draw the lamina. Draw the true shape of the lamina. So we need to draw the true shape. To do that, it's very easy as well. The first thing you're going to do is to draw a line perpendicular to this auxiliary elevation. So to do that, you first of all put this ruler on the auxiliary elevation. Put it on the auxiliary elevation. Put it here, shift it a little bit backward, and you now place this one on it to draw a perpendicular line. This. This is not perpendicular. Let's see it again. Let me place this one under. So you shift it a little bit away, and you can place this one on it. draw this, take it to A2, draw this, and this one is correct. So that is the parallel line. Now the next thing, you're going to draw perpendicular line to this, but because this line is perpendicular to this, so you can just measure the same distance from the left and right of the parallel lines. So I'll come to this place, I'll measure 20, this is 20, then I'll measure 20 on this side too, this is 20. So with this one now, I can now draw this. So that will be x2 y2 line, x2 y2 line. So now what do we do next? We begin to take our measurements. Now this time around, you know, we are working on this. Ordinarily you say we should take our dimension from this, but that is not the direct way to do it. Although the dimension will be taken from this, but not their measurements here to here, here to here, and here to here. Rather, we're going to take the measurement from B, for example, to the x1 y1 line, from A, the distance between here and the x1 y1 line, then distance between C and the x1 y1 line. Those are the things that we'll plot on this side. So to do that, let us use our compass. You can measure and use it directly, or you use compass, but with compass it is easier. Just place it on B and extend it to x1 y1 line. It is here. So you come to x2 y2 line. The video is not showing. Let me take it up a little. From here to this place, you mark the point there. So that will be this point, and this will be B3. Now you come to A again, A as well. From A, like this, let me show it again. From A, you extend it to x1 y1 line, which is here. This is our x1 y1 line. You extend it to that place. Then from there, you move it upward. Here, go to x2 y2 line and mark the point. You mark the point, and this is the point here, and that is our A3. Then finally our C. Measure our C to x1 y1 line, like this. This is the x1 y1 line. So you come to x2 y2 line like this and mark the point like that. So that will be it. So we can now join the point. And this will be our C3. This point is C2, this place, and this is A2, this is B2. Now we connect them together with straight line like this. Like this and like this. So this is the true shape of the lamina. You label it according to the question. It says we should indicate on your drawing the auxiliary elevation, which is this. We have indicated it, and the auxiliary plan. So this one is called the auxiliary plan. This one, let me put arrowhead. This one is the auxiliary plan. Or true shape. So, and what we are also directed to indicate, to measure and state the true length of AC. AC, you have to measure it now. This is our AC. So that's A3, C3. You come here, measure it. What do we have? 1, 2, 3, 4, 5, 6, 60. It is 60 millimeter. So you write it clearly there. So that is the solution to the question of West Africa Senior School Certificate Examination of June 2014. Question 2. So if you have enjoyed watching this video, please like the video, share the video, and subscribe to my channel if you have not done so. Thank you very much for watching. We'll meet in the next video.